Welcome everybody. We have been given this question: integral negative pi over 2 to pi over 2 x squared times cos x over 1 positive e raised to the power of x times dx. Now we know this formula: integral a to b f of x dx is equal to integral a to b f of a positive b negative x times dx. So I can rewrite the above integral as negative pi over 2 to pi over 2. So this is going to be negative pi over 2 positive pi over 2 followed by negative x whole squared and cos of negative pi over 2 positive pi over 2 negative x divided by 1 positive e raised to the power of negative pi over 2 positive pi over 2 negative x times dx. Negative positive goes off, negative positive goes off. This is negative pi over 2 to pi over 2. Negative x raised to the power of 2 is x squared. This is cos of negative x, and this is divided by 1 positive. Negative positive goes off, giving me e raised to the power of negative x dx. Now cos x is even function, so that means cos of negative x will be equal to cos x. So I can rewrite this as negative pi over 2 to pi over 2 x squared times cos x divided by 1 positive 1 over e raised to the power of x times dx. I can further rewrite this as taking e raised to the power of x as the LCM. This is e raised to the power of x positive 1 divided by e raised to the power of x, and you have x squared cos x in the numerator. So I can flip this and rewrite this as integral pi over 2 to pi over 2 x squared times e raised to the power of x times cos x times dx divided by e raised to the power of x positive 1. Now on the left you got I take this as 2, I take this as 1. Adding 1 and 2, I will get 2 times I is equal to integral negative pi over 2 to pi over 2 x squared times cos x dx divided by e raised to the power of x positive 1. Positive second integral negative I over 2 to pi over 2 x squared times e raised to the power of x cos x divided by e raised to the power of x positive 1 times dx. Now what I can do is I can actually rewrite this as x squared cos x can be taken out. I will get 1 positive e raised to the power of x times dx divided by 1 positive e raised to the power of x integral negative pi over 2 to pi over 2. You have 2 times I. Okay, so they get cancelled, giving me negative pi over 2 to pi over 2 x squared times cos x times dx. Of course we got only 1 as a denominator. Now this x squared is even function, cos x is even function, so I can rewrite this as 2 times integral 0 to pi over 2 x squared times the cos x times the dx. On the left you have 2i, so 2 gets cancelled, giving me I is equal to integral 0 to pi over 2 x squared times the cos x. Now I'm going to use Lie concept, so u will be equal to x squared, du will be 2x dx, my dv is going to be cos x dx. I integrate this, I get v is equal to sin x. So putting it in the formula, uv negative integral v du, you get x squared times my v is sin x, the limits are 0 to pi over 2, negative integral v is sin x, and du is 2 times of x times dx. Now I substitute the upper limit, I get pi squared over 4, lower limit will be 0, sine of pi over 2 is going to give me 1. So this one will be a lie, okay. So followed by 2 times of, now I need to apply uv formula again. So u is equal to x, du is equal to dx, and dv is equal to sine x. Integral of dv will be give me y, integration of sin x is going to give me cos x. So using the formula uv negative integral v du, This is going to be pi squared over 4 negative uv. U is x, my v is cos x, and the limits are 0 to pi over 2. Integral v is negative cos x, so it's going to be cos x times du is dx. The limits are 0 to pi over 2. Now I substitute the upper limit, I get 0, lower limit I get 0, so this goes off. So this is going to be pi squared over 4 negative 2 times I integrate cos x, I get sin x. The limits are 0 to pi over 2. I substitute the upper limit, I get 1, so this is going to be pi squared over 4 negative 2. Okay, so this is the final solution. Please like, share and subscribe. Thank you everybody.